This is not news, but we're sort of midway in this process. We're of course heading towards a future where there's a lot of interest, not only of course in these technologies, but how to think about organizing them. And so I'll use this as a motivational picture. If any of you are using LangGraph, this is kind of a great picture. But just there's a lot of investment, and right now in 2025, one of the big questions is ROI, right, about these technologies. So there's a lot of interest and investment in trying to figure out how to get these models to work and to get them to work together. Now, depending on how you use them, like Crew AI, this is from LangGraph, there's others that will happily tell you sort of how to think about taking these models and not just using them, but thinking about using them in combination with one another, whether or not you should have a manager, whether or not you should have a supervisor. I want to use this just to motivate the key point of this paper before I move on. So a lot of firms are thinking about how to organize models in a workflow, and that includes people in this room. Even if you think about a language model with a human evaluator, that is an organization, right? It's an organizational choice. So even the simplest of these things are organizational choices. Here's the central point of this paper, the story we're trying to tell. Especially as we think about ROI in this particular context, is that when we think about LLMs, given the fact they're stochastic and non-transparent, as all of you already know, there's a lot of orchestration work that firms are doing to manage these shortcomings. And so the point of this paper is that a lot of the scaffolding we're putting in place is relatively brittle. And so what that means is that when the environment changes, they lose value very, very quickly. So this key point of this paper is, the point it's trying to make is that we may expect to see depreciation be a very different thing here for large language model investments than we have for other technologies. Right now, of course, scaffolding, especially those of us who have thought about technology, scaffolding is not new. We've had changed organization many, many times. But there's something about the quality of this technology that makes those investments particularly brittle. Just to put a point on it, if you're using a model in a workflow to think about underwriting, if you're in the insurance business, or to evaluate a patent or something like that, if you change models and you change workflow, the output changes in an unpredictable way. That's not a particularly new idea for many of you in this room. You all know that it takes a lot of work to figure out the right model and right configuration to put together for a particular task. But if it changes in an unpredictable way, if it's very sensitive to external conditions, that has big implications for investment because it means depreciation is big. It means that investments that worked yesterday don't work tomorrow. That's not true of enterprise systems. It's not true of rules-based systems. It's not true of other things. And so as we think about ROI, that's the main point we're trying to surface and think a little bit about. It turns out that a lot of people have spent a lot more time, I don't know if there are any organizational theorists here, but they've spent centuries thinking about this broad problem. One way to think about this, right, if we think about generative AI as supplying artificial expertise to the world. Now, we are certainly having a lot of fun as people thinking deeply about how to organize that, but if we think about how to take a model and build it or to prompt it, I think those are all, like I've seen a bunch of fascinating papers today on that topic, but realize we have entire HR departments dedicated to that in organizations, right? How do you manage expertise? Like we've built infrastructure over years and years in terms of how do I select and grow expertise in a way that's efficient for the organizational form that I want. So there's a lot of theory, a lot of investments that go into how do I take expertise, select it, and then put it together to make it work. So generative AI causes this kind of new problem. It creates an abundance of artificial expertise. Some of the classic organizational problems, and these are, if you think about the huge names, right, the big hits like Chandler and Sloan and like Herb Simon, right, they're all talking about organization. How do you organize to account for something like bounded rationality? Right, or those sorts of things. They're all talking about this for decades. These are super important points. And one of the points we're trying to make is that some of these problems are going to or should be brought back into the conversation as you think about how to organize agents, whatever workflow we choose, because this is going to have implications for how we think about some of these. So a key point from this literature is that when you do choose an organization, then it's exposed to a couple of types of risk when the environment changes, when the technology changes, or when the environment changes. This is what a lot of organization theory is about, is exposure to risk. Same points here. We're talking about artificial expertise now. When we put a LLM workflow together, same thing. It's very sensitive to external risk, either organizational or technical. So that's the same idea here. Firms put a lot of effort into putting together models and configurations. The idea is to maximize. This is from the org theory literature. A lot of, again, these are ideas that have stood the test of time for a lot. They use different language. They talk about commitment and inertia, the fact that once you choose a configuration, you're stuck with it. It's hard for us to kind of move to a next thing. So it's a choice you make. Same idea with an LLM workflow potentially, right? Once you choose and find the optimal choice for your particular problem context, in a sense, you're stuck with it. What does it mean for being able to adapt when the environment changes? Does that produce or new kinds of challenges? So a couple of different kinds of risks. Basically, it's that adaptation, optimization trade-off that we've seen time and time again in different contexts. The idea is that's particularly problematic here with language models because of their unique characteristics, because of their stochasticity, because of their various issues. They're unusually, the scaffolding that we set up, the choices that we make from a workflow perspective are unusually brittle, unusually fragile, and unusually subject to lose value once things start to change. So in that way, it's just a little bit of a cautionary type of point in terms of how we think about ROI. So if you think about, again, how you choose to organize anything, what work theory does is explain how we design roles and routines to work around human limitations like bounded rationality or coordination. You have the same kinds of challenges with language models, right? They exhibit some of these same characteristics. Maybe they're not fully rational. Sometimes they can be deceptive and so on. So as we think about putting organizational structure in place, whenever we choose a configuration, whether it's between AI and LLMs or a team of LLMs, it's subject potentially to the same kinds of challenges. I think this is related to technical debt. I'm not sure. This is not a term they use in other, maybe in all fields. Some don't, some do, some don't. There's been a lot of talk about technical debt with generative AI, mostly in the context of vibe coding. But you could also think about it perhaps in this way, which is that if you are making these kinds of investments, you're accelerating technical debt more quickly than you might be with enterprise software or rule-based software. This is another example of large language model investments kicking the can down the road, in a sense, right? You get the workflow working today, but to what extent is that driving or accelerating technical debt in the next 5 years or 10 years? And that's part of the message of the paper, is essentially it's fast-forwarding technical debt. Okay, so this is the basic research question here. Does the architectural compromises that we make to manage its shortcomings, many of were, if you were going to the papers and sessions today, you heard about a lot of different examples, AI, human configurations, human evaluation harness loops, and so on. To what extent did those accelerate or increase organizational risk or the accumulation of technical debt? And our approach here is going to be to start with a number of tasks, but run them across different configurations to understand as you move away from if you optimize sort of a workflow and a model for a particular task, and you start to move away from that task, either in terms of the model or the configuration, how does it start to affect performance? So if you're using a team-based configuration, how robust is that to different tasks, or is it unpredictable? So I'll talk a little bit more about that in a minute, but I want to keep true to my promise of ending earlier. I'll tell you the problem context we're starting with, because the data are quite cool for just completely separate reasons. We wanted to start with a context that matters. We're going to start with the valuation of ideas and innovation. That's what venture capitalists do. It's what private equity people do. It turns out in technology transfer offices in the universities do the same thing, which is we have scientists that are working on ideas. We want to be able to figure out how to take them to market. So we're going to get all this data from these universities on how to value scientific innovation. This is a cool data set because it's rich. It's also very text rich. It turns out this is also a very, very difficult problem. So if you go out and you talk to people at technology transfer offices, it's very difficult to figure out to what extent somebody working in a biochemistry lab at UPenn is going to build something that's actually valuable out there in the field, that's going to make a lot of money. And to make this point, you don't have to look a lot farther than the mRNA vaccine, which my employer let sit dormant for a decade or two, right, before they actually, now they make a ton of money off of it, but it was just sitting there undiscovered in a sense. So universities generally are not great at this particular task. And so if you talk to any of them, a lot of them are just looking for help. They're just like, help us take this mountain of data and figure out how much it's worth. And you can imagine, of course, why it's a hard problem too, because if you or I were to look at a biochemistry filing, like what am I gonna do with that? So you gotta pull together people from different parts of the university, and it's just a hard problem. So anyway, this is the problem context. We like this for a number of reasons. This is an example, right? So we have all this data that looks a little bit like this. We have this new thing we invented, and here's the landscape, here's how it works. And so it's nice because this is an open-ended task with no correct answer. There's a big literature, right, by the way, on valuing innovation. Maybe some of you are familiar with it. This is new to me. It's a team-based task. Our data contain the ground truth, which is cool, because we actually know how much they were licensed for and the ongoing revenue fees year after year. Another nice thing with data they're proprietary, so there's no memorization issues with these language models, right? They're all private to the universities. All right, so the idea here is to essentially change technology, change organization. And so if you think about starting with one task, we're gonna look at others as well, we're just starting here. But if you think about a task like this and think about what is the right model to use, what is the right configuration of agents or specialization, whatever it is to use, how do they perform? And then as you start to move away from that fixed point, how quickly does performance start to fall off? That's the general idea and the general approach. And again, that part's relatively new. Love to hear your thoughts and feedback. And like I promised, we're going to finish up in a minute or two here. So we do. There's certainly evidence, by the way, that organization matters. And this is probably not new at this point. Maybe for some of you it is. But if you take language models and you start to think about how they make decisions. So what this is basically saying is, if you're looking at the valuation problem, here's a solo model, here's a model with a hierarchy, but a flat hierarchy versus like kind of a heavier hierarchy. So how you put them into an organization matters for the kinds of valuation decisions it makes, which is again, that's the point of these like Crew.ai or places like that, or LangGraph. That's the point they're trying to make. But the other thing, and I apologize for this graph, but this is about the time I got my third email from Carol Heller about my slides being late. So they're just not so pretty. But the basic idea here is that as we start to, these are sensitivity tests in a sense, of basically trying to move or alter these points a little bit, maybe change the model just a little bit from like, I can't even look at the numbers here, a 3B model to a 7B model or something like that. And you see these relatively, it's not a smooth progression. It's a relatively dramatic change in some of the performance in these different things. For some models, if you have two specialists, it works better than having a single specialist. The point being, I know I'm going quickly here, but the point being that it's very unpredictable about which of these things is going to work well even for a given task, right? So if you think about taking two agents, putting them in a hierarchy, it works for one model, but as soon as you move on to another model, that kind of falls apart. So they're relatively fragile that way, and we're curious, thinking about the implications of this for investment. Okay, I do have 5 minutes left, so I do want to stop and give the time back to you, and your comments are very much appreciated on how to take this forward. Yeah, Alok, please.
So just a clarification.
Yeah.
You said that data is proprietary, but most of the data would be in patents, right? I mean, so most of the monetizable technologies usually go through patent process, so there will be some disclosure.
So we have licensed data, right? So some of it goes to patent. We have, not all of it does, right? These are, it's all the data that comes in from the inventors, and then I think for some subset of them, they take them to the patent office. And then there's even another subset where you can not patent, but also license them to someone like Pfizer. So it's possible. I don't know if they have the revenue numbers would be recordable, but yeah, it's possible the patent database does make it into, that's fair. Yeah, it is. It's interesting to see that. Yeah, Ashish.
So again, some clarification.
Yeah.
It seemed to me earlier the way you pitched this was you were trying to tie to the org queue, right?
Yeah.
Where people interact in a certain way, and you use that model to design organizations, right? Whereas what you are presenting here is like a multi-agent system, and you're relying on all these black box statistical properties and how these different agents come together to solve a particular problem. So I was not able to make that connection.
Yeah, so let me try to clarify the pitch. The pitch would be that a central feature is of org maybe design is that it causes like inertia, that once you make a commitment that when the environment changes, you're in trouble. And the idea is that to the extent that we're making the same design choices as part of the LLM stack here, because of its various features, we have the same kinds of inertial type issues that are going to arise in a different way than they have for enterprise systems. Is that pitch make sense? Okay. Okay, Michael? Yeah.
So, related to the previous two points, the wisdom in the org crowd is that the value of each of the configurations depends on the nature of the task at hand and the environment.
Yeah.
And I think that if you were to transpose the same principle, you would be in a really interesting place where you're like, under these conditions,
Yeah.
you should deploy GenAI in this way or that way.
Yeah.
The challenge
Talked about
here
this,
is
yeah.
that you're essentially saying,
Yeah.
it's a flat world, and I'm going to tell you why A, B, or C are correct.
Yeah.
The question is, are they off diagonal or not? Are they the right configurations for the right task? One proviso, is this task so specific that you would see the results not generalized beyond that? That has to do with the first comment in terms of patterns. And the second thing is, if you take the analogy a little further, great. What structures work in what conditions?
Yeah.
So I think that I would encourage you to think about conditional, not universal organizational principles. This is what we have learned in terms of any empirical studies of the merits of different ways of organizing. I suspect that AI will not be able
Yeah.
to do that logic.
So let me just speak to that. I was looking at DK a little bit, but we have another project that basically tries to divide the world into what are the four quadrants here, but essentially looking at different problem contexts that require creativity, that require top-down command and control, and then I think to your point, trying to map that back to which organizations are best in those contexts. So I think that is an interesting place to be thinking as well. Yeah.
Awesome. So thank you so much, Sonny, and thank you for all the presenters. We're going to have a 20 minutes break, and we invite you to the plenary session on the larger room at 4:20.